The goal for today's lesson is I can choose the defining attributes of 3D shapes. We've talked earlier about 2D shapes. Remember, we said that 2D shapes are flat. 3D shapes are shapes that are not flat. So, for example, this tissue box is not flat, where a square is flat. We're going to look at some 3D shapes and we're going to talk about what makes them those shapes. So it's going to be kind of similar to that lesson that we did a few weeks ago about looking at the attributes of 2D shapes. So I think this will look a little more familiar once you see what I mean. So are these 3D shapes the same? What's the same about them? Well, there are different colors, different sizes, and they're in different positions. That means, see how this one's crooked, this one's standing up, that one's standing up. But that doesn't matter, they are all the same shape. This is what we call a rectangular prism. You see how there's a rectangle here? And it is a prism. That means it's 3D. So it's a bunch of rectangles put together, and there'd be some more back here. This tissue box is an example of a rectangular prism. See how it's just a bunch of rectangles on each side? And obviously, yes, they are the same. We define 3D shapes by the number of faces, edges, and vertices. We'll talk about those in a second. We don't worry about the color, the size, or position of the 3D shape. Just as I was saying a minute ago, what we said about 2D shapes, doesn't matter what color or how big it is, or if it's straight up or sideways or crooked like that. It's still all the same shape because, well, they have three things in common. One, they have the same number of faces. What's a face? A face is the flat surface. So, for example, look at this tissue box. You see how this is flat right here? So that'd be one face. That's two faces. Three faces. Four faces. Then on this side you have 5 and 6. So the rectangular prism has 6 faces. That's 6 rectangles put together. Then it also talks about edges. So going back to this tissue box, an edge is where the two faces meet each other. You see that? Another way to remember is like if you were walking on this and then you would fall off the edge. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A lot of edges. There's 12 edges in a rectangular prism. Just because shapes are the same size and color does not mean they're all the same shape. So these are all green shapes about the same size, but obviously they're not the same. One is a rectangular prism. We just talked about those. A cylinder is like a can. If you've ever seen a can of soup, that would be a cylinder. And then this last one's a sphere. It looks like a circle. It's kind of hard to make a picture of a sphere. A sphere is like a ball. So a basketball, a soccer ball, all those are spheres. They're not flat like a circle is. So yeah, those are all different shapes even though they're the same color and size. What's true about all cones? Okay, let's talk about cones for a second. A cone is just like what it sounds like. It's like it's shaped like an ice cream cone, or maybe an orange cone that you've seen outside. Maybe like a birthday hat. Those are all examples of cones. All cones are purple. Well, obviously we know that's not true because we've seen orange cones and brown ice cream cones. One vertex. Okay, the vertex is like the vertices. Remember, those are like the corners. Is there a corner on this cone? And yes, there is, right up here. And so there is one vertex, big. Well, now a cone can be any size and can roll. If you were to put this on top of a hill, it would roll down. So yes, all cones have one vertex and they all can roll. They're not purple or big always. What's true about all spheres? Remember I said a sphere is like a ball. 0 vertices. Just like a circle, a sphere is round and there's no corners, there's no vertices, so that is correct. Cones have 0 vertices. Cannot roll. Well, if you put a ball at the top of the hill, you all know the ball's gonna roll down it. So that's not true. A ball actually can roll. A sphere can roll. Big. Well, baseballs are small, basketballs are big. So no, they don't have to all be big. And 0 edges. Remember, the edge is where the two surfaces meet, like right here. Well, a ball does not have any edges because there's no vertices, no edges. So the two correct answers is that it is 0 vertices and 0 edges. What's true about all cubes? A cube is just like a rectangular prism, but instead of being a bunch of rectangles put together, it's 6 squares put together. So notice how each face is a square. Like a dice would be an example of cubes. You've probably heard the term ice cubes. Well, that's where it comes from. It comes from cubes of ice. What's true about all cubes? They're all colorful. Obviously, a dice is not colorful, so no, cannot roll. Okay, if you put this cube on top of a hill, it might slide down, but it's not gonna roll around. So that's correct. A cube cannot roll. The reason it's not gonna roll is because it's not, all these faces are joined together in a way that it's gonna slide instead of roll. All small. Well, cubes can be any size, so no. All have 12 edges. I know you can't count the number of edges on this. You might remember earlier that I said that rectangular prisms have 12 edges. Well, cubes also have 12 edges. Remember, the edge is like this right here, where the faces meet each other. So the correct answers were that they cannot roll and that they have 12 edges. And stay tuned for the next video to see the rest of this lesson.